Good morning, students. Most welcome to this virtual classroom of class 9th that is being conducted by St. Paul Modern School, Bakri Bazar, Begusharai. Today we are going to read one chapter from your chemistry book. The first chapter, Matter in Our Surroundings. Matter in our surroundings. In the beginning, we have to be sure that we know one or two terms, exact definition of one or two terms. Because sometimes we used the two words, matter and substance. Look at this. Read it very carefully, and if you want, you can note it down also. Matter is anything that has mass and volume. Volume means it occupies space. Anything that has mass and occupies some space is called matter. Number two, when we classify matter according to either physical or chemical properties, we call them substances. According to physical properties, they will be solid, liquid, or gas. According to chemical properties, they will be elements, compounds, and mixtures. You got it? We interchange the meaning of these two words in our daily life. Sometimes we say matter when we mean substance. At other times we mean substance, but we call it matter. But in the science classroom, we must have a clear definition of what I am going to say. So, at the outset, in the beginning, let us clarify what is matter and what is substance. What is the difference between these two? In your earlier classes, you have already read a definition of matter. Matter is something, matter is anything that has some mass, has some material, it is made up of some material that you can touch, that you can feel, that you can see. Through one or more of your sense organs, you can perceive it. The matter has mass. And secondly, it must occupy some space, that is, it must have some volume. By this definition, anything we see, anything we can feel, like air. Air we cannot see, right? But we know that air is there, we can feel it on our skin. Air has some mass. How do we prove it? Take a football or volleyball. You weigh it. And then let the air out of it. Deflate the ball. And again you take the weight. You will say, see that the weight is coming a little less than the previous inflated ball. And that very little amount of air also carries weight, it will be proved. So anything that has mass and that occupies space, air and water, hydrogen, oxygen, sugar, sand, silver, steel, copper, coal, iron, wood, ice, alcohol, milk, oil, kerosene, petrol, carbon dioxide, steam, carbon, sulfur, rocks, minerals, all are different examples of different kinds of matter. So, it is very easy to define matter. Matter has volume, matter has mass. So, what is substance? Substance is the moment you begin to categorize the matter, either according to their physical properties or according to their chemical properties. if you categorize all matter according to their physical properties, physical characteristics, you will see that they are classified in three broad types: solid, solid substance, liquid substance, and gaseous. The chemical composition may be the same, like water, H2O. The chemical composition is same, but you can find it in solid form in ice, water liquid form, water vapor steam, it's in gaseous form. So, according to physical characteristics, matter can be divided into three kinds of substances: solid substance, liquid substance, and gaseous substance. According to their chemical properties, we can also broadly classify them into three parts. That is, the elements, compounds, and mixtures. About them, about the chemical division, we will read about them in the next chapters. In this chapter, we will define matter according to their physical characteristics. Up to this, we are very clear. In this chapter, we will read about solid, liquid, gas. You may be asking the question, sir, we already know what is a solid, liquid, gas. We have learnt about them in my previous classes. What it is that will be different to read about the same things in a class 9 classroom? Yes, you know, everybody know what is solid, what is liquid, what is gas, and we have already read something about them in our science classes. But from class 9, we will read about these three fundamental states of matter from a new angle. We will read the kinetic theory. What is kinetic? Kinetic is that kind of energy that induces motion in a particle in a body. Heat energy, light energy, when it is given to a particle, small body, and it induces motion in it, we say that the heat or light or the other forms of energy are converted into kinetic energy. In this class, in this period, we look at the solid, liquid, and gases from the angle of kinetic theory of matter. Look at this. Kinetic theory of matter, it is based on, basically it is two axioms. Matter is made up of innumerable tiny particles, very small particles, and these particles are always in motion. And it assumes two further axioms, that if these particles are always in motion, these particles must have some space, that means distance between them, and in spite of having some distance, the fourth axiom is this: these particles are also attracted to one another by a force of cohesion. Please note it down, and then we will try to explain this further. Kinetic theory basically tells you two things. Number one, any matter, any substance, they are made up of innumerable tiny particles. Number one, innumerable, countless, millions, billions of small particles. How small? They are so small that it cannot be observed even through very powerful ordinary microscope. Only very special electronic microscope can give us a very little glimpse about what these small particles look like. We either call these small particles atom or we call them molecules. You will have some idea about the smallness, if you look at this picture, it is a drop of little small drop of rainwater on a leaf. Even this rainwater drop has, you see the number, can you count how innumerable? There are 10 to the power 21 particles of water in this small drop. So you understand how little these particles must be. So all substances are made up of innumerable small particles. First part of the kinetic theory. How do we prove it? Let us do some experiment. You can do it at home, and since the school laboratory is not available here, so let us not use any special chemicals because it may be unavailable to you in your home, and also it may be dangerous. But in the laboratory, we usually do it with the crystal of potassium permanganate. Potassium permanganate, that crystal of potassium permanganate is purple in color. If we take a beaker of water and put a crystal of potassium permanganate in it, we'll see that very soon the color of the water will start becoming purple. Look at this picture. We have put a crystal of potassium permanganate, which is purple in color, in a glass of water, beaker of water. You see, very soon the crystal of potassium permanganate is broken up into small particles of potassium permanganate, and in the third picture you will see how the particles of potassium permanganate are spreading through the particles of water. Now come to the board so that I can explain it in a little better way. Look at the board. Let us put a very simple illustration on this point. Say this is a beaker of water we have taken. There is some water in it, and we put some potassium permanganate crystal in. After some time, this is purple in color. After some time, we see that the whole water becomes purple. How is it possible? Unless we have the water is made up of many tiny particles, and also the potassium permanganate, the crystal is also made up of very tiny purple particles. What happens after some times, that water breaks down these small particles of the crystal and they begin to move around and make the whole water purple in color. Unless both water and the potassium permanganate are made up of very small particles, it will not have been possible. At your home you can do this experiment in a different way. We are doing it every day. Take a glass of water and put some sugar in it and stir it well, it will dissolve. The color will not change, but you will know that the sugar has spread throughout the water, because the water will now taste sweet. So first part of the kinetic theory, that any matter is made up of innumerable, countless, infinite number of small particles. Very small. Second part is that the same experiment proves that the small particles are always in motion. They are always moving. They must have some kind of kinetic energy in them. Always. These 2 points keep in mind, and we will now explain what is solid, what is liquid, and what is gas. this kinetic theory of motion. Two axioms. Matter is made up of very small particles and matter. The particles of matter, be it atom or molecule, they are always in motion. Naturally, you see, if we look at these 2 points, we get 2 more points out of it. Matter has many particles and they are in motion. If we take them as true, there is a third axiom automatically comes in mind, that these particles must have some space between them. They must have some distance between them. There must be some interparticle space between the atoms and molecules of any matter. That is the third axiom that comes from the first 2 axioms of the kinetic theory of motion. And there is one more point that also comes out of these 3. What are the first 3? Matter is made up of particles. Number 2, these particles are in motion. Automatically we know that the particles must have space between them. And now we know these particles, although they are keeping distance from each other, they are in motion, but they also must have some force of attraction. They must feel some attraction between them. Otherwise, there would not have been any matter, any substance in this world. It will be only made up of many atoms and molecules. In spite of having the distance between them, these molecules and atoms must also feel attracted towards each other. We call it in our science class the force of attraction, force of cohesion. Now we have the full kinetic theory about the matter in full. 4 part. First part, innumerable small particles make up any substance. Number 2, these particles are always in motion. Number 3, they must have some space between them. Otherwise, how can they move? And if they are always moving, why don't they just go away from each other forever? Because they also have some force of attraction working between them. Let us do some experiments to prove these 4 parts. Innumerable small particles. Let us take a simple experiment again that you can do at home. Actually, potassium permanganate is not the factor. You can do the same experiment at home. With a glass of water and a little ink, a drop of ink, it will spread through the water. We call it dissolving. Let us do an experiment with a drop of ink, whatever, at your home. Take, say, 5 glasses. 5 glasses, right? In the first glass, fill it up with clear water. And the other glasses, just half fill them with water. Now put some ink or color in the first glass. You can use the liquid color you use in the time of Holi. You can also do it. Very soon this glass of water will become color. We have already seen that the small particles they spread through the particles of water. But how many particles? We are telling that innumerable, countless. From out of this full glass of colored water, pour half of it in this glass and make it full. Only half part will be colored, and very soon you will see that the whole glass of water is becoming again colored, though you have not put any separate color in it. Again, put half of it in this glass. The color will be a little lighter, little less dark, but the color will be there. Put again the half of this glass in this glass, but you will still see some trace of color in this glass also. Again you put in here, you will see that the color persists. The trace of color is still there, although you are diluting the solution again and again. That proves that with a very little drop of ink, actually there are countless billions of particles. Now look at this diagram. Look at it very closely. You see, in the first beaker, there is concentrated solution of potassium permanganate and water. In the later beakers, gradually we went on diluting the solution. And when we come to the last beaker, the most diluted solution, same solution, we have just gone on adding water, more water to it. How the color has changed. At the beginning it was deep purple and it has now changed to very light pink. But the point is that the color persists, that so many particles of potassium permanganate was in that very tiny crystal in the first beaker, that they are still persisting at the last beaker. Right? That is the first part. Second part, we told you that how do we prove that it is in motion? Of course it is in motion. But in the laboratory, we do it with potassium permanganate if we want to dissolve the solid into liquid. Sometimes we also take a gas jar, two gas jars. One we fill with bromine vapor. You know what is bromine vapor? Bromine is actually a reddish brown color liquid. It turns to vapor very easily. If we put bromine vapor, which is a little heavier than air, and put a black gas jar that is full of ordinary air, cover it on the first jar. After some time, we will see that both jars are becoming full of vapor, bromine vapor that is reddish. Here is a better diagram. Look at it, you will understand it fully. You see how the first bromine, or you can also use nitrogen dioxide in a laboratory, not at home. How the heavier gas from the lower jar, it fills up the upper jar also, and also air is light, it will come down. How these two gases are diffused through each other, right? How is it possible that the air is lighter than the bromine vapor? Bromine vapor is heavier, but they are moving at the same time. The particles are both air and both bromine vapor, they are in movement. This we call diffusion, the mixture of two gases without any extra induction of force. Now you see, this proves that particles are always in motion. In this context, we remember one particular scientist named Robert Brown. Now this person, Robert Brown, in the year 1827, he did an experiment to prove that the particles are always in movement. It took very small pollen grains from flowers and put them on still water. There was no movement in the water. But what he observed after some time, you can also observe it by yourself at your home. Put some pollen grain in a bucket of water. Let them float on the surface. After some time you see the pollen grains are by themselves moving here and there, it's to and fro movement and zigzag movement. This motion, the zigzag motion of pollen grains or particles on the surface of water or in the air. This motion is named after this Robert Brown. It is called Brownian motion. Here is the diagram for you. You see, the pollen grain is shown by the red dot, how it is moving in a zigzag fashion in the surface of the water. Because the water molecules are moving here and there themselves, and there in the process of movement they are knocking the pollen grain here and there. It is called the Brownian motion. How this Brownian motion happens? Unless the particles of water are moving, what happens is that the particles of water are constantly moving, and the pollen grains, they are being treated by these water particles as a football or as a carom board striker. They are knocking them from this side to that side, this side to that side. This proves that particles of water is always in movement. You, at your home, you have already seen it sometimes. Actually, it's a very fascinating sight. In my childhood, I also was fascinated by this particular sight. Go to a room in your house. It must be done in the daytime when the sunlight is there. You close all the windows, shut the door, switch off all the lights. So there is no light in the room. It's a dark room. Now open one window, a very little bit. A tiny gap should be there through which only a single sunbeam, a beam of light comes in. You know what you will see? You have seen it a lot of times. You will see that lots of dust particles are actually dancing within that beam of light. Now dust particles are there in the air, but why they are dancing, why they are moving here and there in the Brownian motion, zigzag motion, to and fro motion? In the air it looks like dancing. Because the particles of air themselves are moving, and although the air is quiet overall, there is no movement in the air, no wind. But the particles within the air, they are moving, and in the process, they are hitting the dust particles all around. So, the diffusion, dissolving, and the Brownian motion all proves the second axiom of kinetic theory of motion, that the particles of matter are always in motion. It has been also observed that if you heat the water a little, the motion, Brownian motion will increase, the rate of motion will increase faster. So, we understand that heat energy, it becomes converted into kinetic energy and increases the motion in this particle. Keep it in your mind. You will need it, this particular kind of knowledge, a little later on this chapter. Third part is, these particles must have some space between them. It is obvious. You don't need proving it. But take a glass of water at your home, say 100 milliliter. That's small. You know the weight of the water, weigh the glass full of water, and also mark the water level with some pen. Say this is the glass, this is the water, 100 milliliter. You mark it here, that water level is here. Now you put 50 grams of sugar in it. 50 grams of sugar, stir it very well. The sugar will dissolve, it will disappear. glass will become, the water in the glass will become sweeter. And you know, if you weigh the glass, take the weight of the glass, it will be increased by 50 grams. But what will surprise you? That the level of water will remain the same. How is it possible? There are more particles in it now, in the same volume of water. Unless the water particles already had some space between them, in which the particles of sugars are now put in, hidden themselves. So this proves very easily that there must be interparticulate space. The fourth part. Matter having innumerable particles, they are always in motion, and they also have some space between themselves, but the particles also have a force of attraction working between them. They are attracted to each other. We call it force of cohesion. C-O-H-E-S-I-O-N. How to prove it? Again, do it at your home. When you come back to the actual classroom, we'll do some experiment with the real chemical substances in the laboratory. But at your home, it is less dangerous, but at the same time, equally educative if you do it with the simple objects at home. Take a piece of chalk. If possible, find some ice cube. If not possible, take a piece of brick from the roadside, or break a brick into shop. And take one iron nail, एक लोहे का काठी, and get a big hammer. So this is the chalk, this is the ice cube or brick, and this is the iron nail. And you get a big hammer and hit all three with the same force, very much force. What will you do? The chalk will immediately turn into dust. The brick will take a little more force to make it dust, little more hammer. And this iron nail, it will change shape. But however much you hammer with this ordinary hammer, it won't turn into small dusty particles. Now, it proves that the particles in this chalk, they were less attracted to each other. So with a little force, we have broken them apart. We have separated them. The force of cohesion, force of attraction, were a little more stronger in the brick. So it took a little more effort to break them apart. And in the case of iron, the force of cohesion is very strong. And that's why you cannot break down it into small particles by ordinary hammering. This proves that there are a force of attraction between this. Now we combine all these four parts of kinetic theory and explain according to this light. Four parts: innumerable particles. Second part, the particles are always in motion, that they have some kind of kinetic energy working in them always. Third part, they must have some space between them. And the fourth part, that they are also attracted to each other. All this we put into theory in class 9th, and then explain why some substance may be solid, it may be liquid, it may be gaseous. Let us keep our discussion up to this point, except that for the next classes, what we will discuss, we will give the basic characteristics of solids, liquids, and gas upon 5 points according to this light of this kinetic theory. From today only, whatever we have taught up to now, let us revise one more point, once more. Matter, anything that has volume and has mass. Matter classified according to physical characteristic, chemical characteristic is called substances. Substances according to physical characteristics can be divided into solids, liquids and gas. And we explain these 3 steps. By the way, we can also mention as a general knowledge here, actually there are 5 states of matter, not 3. There are 2 extra states that the scientists have proved, apart from solid, liquid and gas. One more state is plasma, and the 5th state is Bose-Einstein condensate. You don't need to read about this in this class. It will be in the upper classes science. But as a general knowledge, you should also know it. And if possible, you would go and look up about these things in your internet, if possible, if you are interested. Just for interest, you know who is Einstein, but who was this Bose? You can look it up. We don't need it in the classroom. But as a GK, I mentioned it. Now, according to kinetic theory, what is solid, liquid, and gas? And what is the kinetic theory? Kinetic theory tells 4 things. Matter is made up of particles, innumerable particles. These particles are always in motion. They must have some space between them and they are attracted to each other. In the next class, come prepared with this portion of your chapter in your book. Do the exercises that will be provided to you through us, and you can also do some exercises from the book itself. I am sure in the next period you will come prepared. I am sure that you will be all very attentive about it. And we will go to the next part, explaining the second part of this chapter, matter in our surroundings. Till then, thank you. We will meet you again.